Ladies and gentlemen, dear guests from different nations and industries, welcome to today's special session, DJI Dock 2 Legislation Guidance, Deep Dive into Specific Category of Operations. My name is Irving. I'm Solutions Engineer at DJI Enterprise. DJI Dock 2, as our latest drone technology, helps organizations to perform remote mission efficiently and reliably. And we all know Dock automated solution is the future of the drone technology. But sometimes people are a bit confused about the rules. The regulation from EASA could be a little bit complicated to understand, and that can slow our Dock projects a little bit down, right? If you are interested in integrating DJI Dock 2 into your drone fleet or prepare to deploy a dock for your client, but don't know how to be fully compliant with European regulation, then today's webinar is for you. Today, we are very honored to have two important speakers with us. Mr. Yanas, Head of Flight Operation at OneDrone, EASA specific category instructor, experienced in conducting operations under several STS, PDRA, and SORA scenarios. At the moment, responsible person for specific category operator with 12 different EASA operational authorizations. And we have Mr. Andre. Andre is active compliance manager and commercial pilot with extensive hands-on experience in EASA regulatory framework, particularly in commercial drone operations. His experience includes holding various aviation management positions, such as compliance management, crew training, and flight operations, with a focus on drafting procedures. Also, he's an active expert with several years working experience in National Aviation Authority and a certified IOSA auditor. And today our session, honestly, it's not always free of charge. So yeah. And before we get started, I will introduce our today's agenda. First, we will have Yanas take the stage for half hour to dive deep into specific category. Then we will have Andre to take the mic to talk about more details in SORA and air risk control about Dock 2 in 15 minutes. Then we will use 5 minutes to introduce the documentation support from DJI Enterprise team. Then in the end, we're gonna have the Q&A session. So before we get started, I would like to remember, please put all of the questions in the chat box. So in the end of the webinar, we're gonna bring them up to answer the questions. And besides that, the webinar now is being recorded and later will be made available through a link to all the participants who cannot make it to the session. So without further ado, let's start our first session from Yanas.
Thank you, Erwin. Welcome everybody, and let's start with the look how the specific category works. But first, let me introduce ourselves. We are talking from the OneDrone headquarters in Slovenia. OneDrone is a full solution drone provider. So this means that for our customers, we take care for all the education, all the paperwork, and everything that they need to do to become a legal specific category operator. Specific category, as you will see, it is quite complicated, but manageable, and our company is specialized to offer to big operators like national power grid operators, critical infrastructure companies, and so on. We can provide training, documentation, and everything that you need. So here today we want to talk about how to do operations with the dock. We strongly believe that automatic drone operations are the future of drones, because drone can only be usable and cheap if you remove the man from the equation. And let's go through what does it mean to operate the dock legally and what do you have to do so everything will go. First, let's look into the EASA regulations. You know that across the European Union, we have the same EASA regulation, which we can say that it is like 90% same for each country, and it has like 10% specific for each member state. But we know that we have basically three categories. Open category is a low risk category, which is really easy to do. You register online, you do some online exams, maybe something more, and you are allowed to operate in the open category. But the limitation is visual line of sight. So in open category, we can only operate in visual line of sight with the drone up to 25 kilos, up to 120 meters above ground level, and usually we have to be well away from the people. So everything which is over the limitation of open category, it falls into the specific category, which is a medium risk category. This means that in this category, we can do BVLOS operations, we can do flying over people, and much more. So today's webinar is dedicated to show you what do we have to do to conduct flight operations in the specific category, especially dock operations. First, let's go through some definitions. Visual line of sight and beyond visual line of sight. So visual line of sight operation is defined as an operation where the drone pilot always sees the drone, is able to control it, and is able to avoid the traffic of manned aviation. Everything beyond this is classified as beyond visual line of sight. So all dock operation obviously is beyond visual line of sight, except the testing operation. The second thing which we have to understand is automatic operation and autonomous operation. Automatic operation is something which we are very good aware. This is the operation where the drone does everything by itself, following the pre-programmed plan, and these are operations which we are doing for years, mostly for land surveying, security, and so on. But the most important requirement for automatic operation is that the pilot in command has always to be able to take over the control of the operation. So if any emergency happens, the pilot is always present. And this is also valid for the dock operations. So we are allowed to do dock operations if we have pilot behind the screen who is able to take over the operation. On the other hand, we have autonomous operations, and the only difference is that on autonomous operations, the human is not present and it is not able to intervene. As you know, DJI Dock is very well capable of doing autonomous operations, but in the EASA environment at this stage, they are not supported yet, but we are looking into the future when for sure also the docks will be operated in autonomous mode. But automatic mode is good enough for now. As you will go deeply later with my colleague Andrei, all the specific category requirements are about risk management. Always we have to manage ground risk, which has to do everything with what will happen if the drone will fall into the ground, and for sure there will do damage to the people or property on the ground. And the air risk management, it has everything to do what will happen if the drone will collide with the manned aircraft. When we will go later into the concept of operation for the dock operations, you will see that the ground risk it is very well managed already. So until we don't operate over assembly of people, which is not supported yet, we can fly the dock over controlled ground area, which is usually closed area. We can also fly over sparsely populated areas, and we can even fly Dock 2, which is in the ground risk category below 700 joules. We can even operate Dock 2 over populated area, but not over assembly of people. So we can say ground risk is not a problem. Regarding the air risk, here is something that each member state solves a little separately. So it is not a universal solution, but usually it is doable case by case, as we will learn later when we will look at our use cases of testing the dock. So if you want to do the operations in the specific category, you have to become a specific category operator. And here I will very briefly show you 4 ways how to become a specific category operator. You can do it under standard scenario declaration. You can do it under predefined risk assessment. You can do it with specific operation risk assessment, SORA, or you can get light UAS certificate, LUC, which is a kind of next level in specific operations, and you don't need to have LUC to operate the drones. So let's look quickly into the requirements for 4 of this possibility. Standard scenario is the easiest way how to become the specific category operator. You have to be trained in a certified facility. You must have C certified drones, so at the moment C5 or C6, and you must create operations manual. When you have all of this, you can start to operate in the standard scenario. Hopefully the drone 2 will be C6 certified in the near future. At the moment it is not yet, but if it will be, the standard scenario 2 will be one of the options to operate. However, I think, by my opinion, the best option now is to use one of the predefined risk assessments. Predefined risk assessment is similar to standard scenario, but it does not require C5 and C6 drones, and it is a little more flexible. For example, all 3 beyond visual line of sight scenarios are meant for the sparsely populated area. This means that we can fly over the area which is not closed and gives us quite a lot of flexibility to fly. But in each of the predefined risk assessment, we have to take care for the air risk. So in the GO1, we have to use the observers, which are not the best way to handle air risk, but they are good way for start, because we can do all the testings, all the reliability assurance tests, and I think in most cases the national aviation authorities will require to do the first part of the BVLOS testing with the observer. The second option, the GO2, is flight in the segregated airspace. More of this will explain later my colleague Andrei. This means the airspace where the chance of collision with manned aviation is really low, so-called air risk class A, and we will tell you what are the options. And we have the PDRA GO3. It is BVLOS at very low level. So this is the option which we can use for some linear object inspections, like for example, power line inspection or the railway inspections, maybe also some street inspections where we fly so low that the possibility of air risk is low. And as I told you, probably for the most of the users, the predefined risk assessment will be the way to go with the DJI Dock. But for the users which will not be able to find the solution under the predefined risk assessment, you can also do SORA. This is the specific operation risk assessment. When we take our own case, so our own ground risk and air risk, and then after the risk assessment, we do mitigations, and if we do them correctly, we can fly. Also a topic which my colleague Andrei will explain you in detail a little later. As I have mentioned before, LUTS or Light UAS certificate, it is a form of operational authorization which is meant for more complex operators, absolutely not needed at the time for a specific category, and by my view it is more like preparation for certified category which we will have in the future. But now we will look what are the duties of the operator in the specific category, which are valid for all cases. So if you operate under standard scenario, predefined risk assessment, or SORA, you have to fulfill some requirements. Don't be afraid of our big operator structure. I have just made it to be clear what are the duties which have to be performed in the organizational scheme before you come to the remote pilot or pilot in command. Usually, when you are a small operator operating under standard scenario or PDRA, all the managing duties can be done by one person only, and this person can even be the remote pilot at the same time. But if you are a big organization operating big number of drones, having big number of remote pilots, you must create a kind of organizational structure. So each time on the top we have an accountable manager. This is the guy accountable for everything, communicating with the authorities, and he knows at each time what is happening in his company. Below him, very important, is the compliance manager. In our company, this is my colleague Andrei. As you will see later, there is a lot of documentation to be created. So we need to create the operations manual, we need to create a lot of other documentation, and the regulation is constantly changing. So the compliance manager is the guy who keeps all the documents always in order. Because we know it is a very demanding task, usually small operators use outside companies as we are to create them all the documentation and to guide them through the process of registration at the national authority. The second guy is the safety manager. Also, when you have big organization, many pilots, many drones, you want to have an independent guy who follows all the procedures, and if he sees that something goes wrong, he will intervene and take care inside the company to take the necessary measures so there will not be an accident. And then we come to the three main operational parts: the training part, airworthiness part, and the operational part. We will look at this at our next slide. But first, you need to know that you must have training of the personnel, you must have airworthiness take care, and then you must have operations management. And then there is the pilot in command, observers, and other personnel. So that we come here, let's go through the basic elements of specific category operations, which are valid for all scenarios. So, for standard scenario, for PDRA, and for SORA. First, the personnel of the operator has to be trained. Training organization is very similar to the aviation flying school, and on the training part you have two options. Option one is that you organize your training inside the operator. This means that you create training program, you have instructors, so you can provide basic training, which is everything what has to be done according to legislation. Then you need to do the type-specific training, because each type of the drone it's a little different, especially dock operations are quite different than normal visual line of sight operations and also normal radio line of sight operations, so the personnel has to be trained. And of course you need the operation specific training, because we don't go flying with the drone just to fly legally, but we go flying to fulfill a task. A lot of operators decide that they will use outside organizations, like for example, like we are, to prepare their training programs, to organize the training, and to do everything by the book. And also for the national aviation authorities, it is acceptable that the training is done by the organization who already fulfills all the requirements. The second big part is the airworthiness part. Drones have to be maintained similar like the manned aviation. And here I am really happy that DJI has prepared all the necessary documentation and is really giving us full support to fulfill the airworthiness part. Before, usually the airworthiness part was quite a nightmare for an operator because of the missing documents. But now when DJI is supporting us, it is really easier. Because in each specific category scenario, we have to prove that the drone is fulfilling the technical requirements. This means that all the documentation has to be provided by the manufacturer, so we can prove that the drone is reliable. And I can say that now we have all the documentation supported, and this is now the easy part. Of course, when we obtain the operational authorization, our work starts, and all the drones in the specific category must have regular maintenance. So we must have the maintenance program, which is also provided by DJI, and we must have authorized personnel. This is the personnel who is trained in the training facility, or it can be trained by the producer, by DJI, so they are able to do all the maintenance. And of course the important part is the record keeping, so that we also have all the records about all the maintenance which was done. And finally, the most important part, the operational part. All the operational procedures at any specific operator are written in the operations manual. So in the operations manual, you have templates in the EASA regulations, and also DJI will provide some parts of the operations manual, so it will be easier to create it for you. Otherwise, there is always an option that you get somebody from outside who will help you with this. In the operations manual, for sure, you have a full overview of all equipment and personnel. You have declared how you are doing the record keeping. Basically, in the specific category, you have to follow all your operations. So you must have records. What you do before operation, during operation, and after operation. And of course, we must take care about GDPR, so protection of the personal data. And if something goes wrong, we have to report what has gone wrong, and we must have the emergency response plan. So when we fulfill all these requirements, we can get the operational authorization from the National Aviation Authority. And before I end, I can again invite you, if you need help at any on this part, at One Drone together with DJI, we will be able to help you. Now I am giving the word to my colleague, Andrei Kudrun. He is our compliance manager, so the guy who is creating all the documentation and also the guy who is communicating with the National Aviation Authority to get all the necessary paperwork. So, Andrei, the word is yours.
Thank you very much. Thank you, everybody, for joining. Thank you, DJI, for inviting us. We are really honored to be here at this stage. My part of the prepared presentation before we jump into the questions and answers is going to follow more or less this structure that you can see now. I will briefly do an introduction. We will go a little bit deeply into SORA process, especially in the part called containment. And then I will show you some SORA examples, how we, in One Drone, how we did our concept of operations, what kind of concepts we already did. Focus will be, of course, on dock operation, what kind of options you have, what kind of options you might look into further on. Okay. So let me spend a few minutes about why we are actually talking about so much regulation now. As you know, of course, drones are entering very rapidly now into this industry. The business with drones is growing fastly, and of course, it's entering the same airspace as the manned aviation is using already. We believe that, of course, there is a space for everybody, but we need to agree on certain rules in order to maintain very high level of safety, which aviation is very quite proud of, very proud of. There are three main regulations that are applicable in the airspace in the Europe. First and mainly, it's so-called SORA, which stands for Standardized European Rules of the Air. It's the EASA rule that is applicable for all the member states. Then all the contracting states of the ICAO, they also need to apply the ICAO documentation. It's written in Annex 2 Rules of the Air. Then, of course, on top of everything, all the countries, every countries, they have something locally. As Jan said before, there are some a part of rules that needs to be applied or needs to be taken from the local documentation. Yes, it's true. Drones are flying in quite low airspace, very low airspace, but of course, under no circumstances we can assure that we will not meet manned aviation there. There are rules above. There are rules for the minimum altitudes above which manned aviation should fly, but there are a lot of exemptions where we can find manned aviation also lower. For example, state, military, police, search and rescue, helicopters, they can fly lower as minimum altitudes. We also can find gliders, paragliders at lower altitudes. And at the end, we can also find some planes which are maybe in emergency, which are trying lower in the lower airspace. So by the rules mentioned before, drones need to be able to avoid them. Even if we have segregated airspace, we still need to avoid the manned aviation. This makes quite a big challenge for drafting regulations or actually executing operation in drone business. But there are ways how to do it. As you know, as I mentioned before, the EASA has drafted the so-called implementing regulation 2019-947 and 945. 945 is mainly for the technical part of drones. You can find them together in easy access rules, which you can download on this link. This is the easiest and the most suitable way how you can check the implementing regulation EU 945 and 947. Because easy access rules includes implementing rules, applicable means of compliance, and guidance material. So you have all together listed in the sequence that you wanna have. There are some challenges with this regulation. Of course, as an industry, also regulation is fairly new, and it's also prone to changes. We might see in the near future that the SORA concept, which I will represent now, might be changed with a so-called SORA 2.5. Of course, as the technology is changing, is improving, the regulation needs to follow. And then we have the fact that this regulation needs to meet local conditions, special state requirements. So we need to somehow combine this regulation. At some point, you will see the regulation has so-called open sentences, which more or less means that it's available for the member state authority, for national authority, to do a little bit of its own interpretation. It is, of course, a suitable solution since the legislation needs to be adopted to each member state. Here is one local speciality that our authority did. They implemented build area. You can just, for your reference, see how it looks in this QR code. The good thing is that the regions are defined, and there is no more question whether is this built, is this allowed to, am I allowed to fly here or not. So it's pretty clear, and they did a good job in doing this layer. Let me rehearsal what Janez said about how to operate in specific category. We know STS, PDRA, or SORA concepts of operation. What I wanted to point out that all those concepts are based on the so-called risk-based approach. So EASA, as of course aviation authority, has prepared also drone regulations based on a risk-based approach. So we are talking about risk. We are managing risk. We are identifying hazards, mitigating them, and then we are either accepting or we have to do something else to be able to reach the certain level of safety which we want or which the authority wants. We will focus into the SORA process on the next slide, since this is the most modified way. SORA stands for Specific Operations Risk Assessment, and this is methodology to assess risk. It was done. It is based on the EAROS SORA. EAROS is a group, rule-making group for unmanned systems, and at the moment we are looking at the SORA 2.0. You can find the whole SORA process listed in the before mentioned 947 under the AMC1 of Article 11, which we will go through now in the next slides. More or less in a plain language, I will try to explain what does this risk-based approach means. So, which also SORA at the moment follows. So if you try to develop your SORA, you need to describe or you need to see what kind of operation you have. You need to check your equipment, environment, crew, procedures, and what you're going to do. The next step is you identify, you assess, and classify your risks. Mainly, as Janis mentioned, we are talking about risk related to ground and risk related to air, so-called ground risk and air risks. Additionally, EASA requires us also to consider some environmental aspects, security, GDPR, and so on. We are assessing risk based on qualitative and quantitative methods. And then when we know what our risks are, we might or we want to mitigate them. Of course, we don't want the risks just to be there to pose a threat to our operation. We have two ways how we mitigate risks in a drone business. One is strategic, by applying strategic mitigations, and applying tactical mitigations. Once we did that, we see what our residual classes of risks are, and by those values you will see later, at the end you find which kind of objectives you need to meet in order to be able to fly. So once you know that, you develop your procedures, you train your personnel, you select your team. The work definitely does not end here. You as operator should always continuously monitor your operation. You need to assess the performance of your operation. There are ways how to do it by checking safety performance indicators, key performance indicators. Just do some audits. In one drone, we are doing operational audits, so we can see also what is happening on the field and so on. So you want to have your operation, your risks under control, because it can happen that during your operation you find out that might be some other risks you didn't consider before. If we go deeply, but I will not lose too much time on this, here is a process, here is a tree which EASA, which SORA 2.0 is at the moment following. Interesting part is that we mitigate ground risk and air risk at certain steps. I will briefly show you later. Just to quickly go through these pages, you will see you start by defining your initial risks, ground risk, depending on your characteristics of your EOS and your nature or your concept of operation. You end up with a certain value. Then you have, then you need to assess your air risk, which are considered to be classified as ARC, as ARC from A to D, ARC A being the lowest, ARC D being the highest, the most risk operation. By applying your strategic and tactical mitigation, you find yourself in the residual risk. One interesting thing here is how we lower risk in BVLOS operation, air risk. We have actually three options. Either we apply for segregated airspace, which can be reserved, temporarily closed, and so on. And this brings us to ARC A, which is the lowest air risk. Or if we want to stay in ARC B or C, we can try to meet the TMPR performance requirements. Then, as I said before, technical performance requirements are listed in this table of EASA. You can see that for VLOS, technical mitigation is visual line of sight, and for the BVLOS, it is, of course, by applying those kind of performances. The good thing is that DJI Dock 2 in the technical part already meets the TMPR requirements for the low level, which means for the ARC B. Okay, then you determine your sail, and by this you see which level of operational safety objectives you need to meet. Okay, a few words quickly about the containment, which is the part of the SORA process and also integrated into all the other PDRAs or STAs. We know two levels of containment, basic and enhanced. Basic containment is actually required in all the concepts, and it means that no probable failure will lead to to the operation outside of the value of your volume. Actually, it is about the flyaway. There is one example how this is incorporated, similar or same wording for the PDRA operations as well. Enhanced containment, on the other hand, it is required in certain conditions, and also the technical requirements are different that needs to be fulfilled if you need to fulfill the enhanced containment. As you see, the wording similar included in PDRA examples. Slovenian CAA did a very good job in applying for alternative means of compliance regarding containment, which means that you can fulfill EASA implementing rule by fulfilling the alternative means of compliance. Basically, what they did is they allow the small UAS to fly still within the populated areas without applying enhanced containment. But as long as you have more risk operations as an assembly of people, large crowd of people, or if you're flying with the big drones, you need to fulfill the enhanced containment. On the other hand, also Croatia, they also did their own way how to mitigate air risk, and they actually create a digital solution. They are using the so-called AMC portal. You can check it's a public, you can check it on the link there. What they did is actually a very good solution, because by this, they also notified manned aviation about the drone being operated at a certain location. And by doing this, they changed the air risk to ARCA. And it means that also BVLOS dock operations are possible, are much easier in this way. There are some examples what we did with the SORA. We have to skip, unfortunately, this because we're running out of time. I will just show you a few options how we created a few dock cases. So this is how we did in Croatia. As Jan said before, there is no single unique solution for dock concept of operations. You can either go to PDRA 1, 2, 3. I would, of course, recommend G3 if you're happy with flying very low, or G2 if you are able to meet the segregated airspace requirements, or G1 if you're happy to fly with the observer, which you probably will at some testing stage. We are further looking into airspace, which will solve those problems as well, but it is not. It's quite far away now. There are some PDRAs which EASA is considering to publish. PDRA 5 and 7 might be interesting for us as well, because it's about the BVLOS operations. It's not official yet. As I said, G3 low-level flight might be, as Jan said before, suitable for observing flights. G2 segregated airspace. It's one way to go. I wanted just to quickly show you a few examples what we did in one drone regarding the dock operations. This was one testing area we were using. We were trying to demonstrate the reliability of concept or end of the equipment by flying BVLOS with observer at this area. I like to mention that observer is not a pilot. Observer can be a person which should be trained at a certain level, but it's more or less should be trained how to observe the airspace and how to communicate with the piloting command. And then at the moment we are testing Dock 2 under G1 concept. At the moment with the observer, the final idea of this test protocol would be to demonstrate or to evaluate how we should prepare the solution for SORA without the observer. We are looking in Slovenia to establish the geographical zones which will help us to mitigate the air risk as it should do. So thank you very much. This is from my side, and I give the word back to Irving. Thanks.
Well, thank you guys. Thank you for sharing the very valuable knowledge. Basically, the content what we are sharing today is definitely not free of charge contents, and it's according to you guys year by year's experience. Like the communication with CAA, the cooperation with different drone pilots and team, and the knowledge is really valuable, and appreciate for that. From DJI side, we are, as we just spoken, we are also providing the documentation support as a manufacturer to the markets. I will briefly introduce our documentation. Uh, well, we first provide a DJI Dock 2 technical info based on the operations manual template provided by EASA. Basically, we listed all the technical safety features about Dock 2 and FlyHub 2. And besides that, we're also creating a SORA template for our users. And also, we fulfilled all the technical requirements according to the SORA, including the TMPR, including the manufacturer OSO, and so on. Besides that, we also created several documentation to explain Dock 2 safety features, such as functional hazard assessment report and the manufacturer declaration to declare the possibility of the drone to leave the operational volume, and the robustness report for Dock 2, and of course the user manuals and the maintenance manuals. Hopefully, the documentation could be useful for the market to obtain the operational authorization. And the documentation will shared after our webinar via email to all the participants of today. And if you click in the link and complete the quick survey, you will be able to download it. We still have 10 minutes time. We're gonna bring up all the questions which are in the question box. So if you have any questions, please put it in the box, and we're gonna bring it up now. So the first question: what are the proven way to achieve 50% air detection according to TMPR level low performance in an ARC-B airspace, which is L2, or even 90%, especially in remote areas where there's a lot of non-cooperated air traffic? Yeah. So I believe this question is Yanis. Do you want to answer the question regarding air detection?
I think this is question for Andrei. So do you have any idea how to know that 50% of the aircraft will be detected?
Yeah, as it's written in the EASA rules, you actually have to demonstrate to the authority. You can use either local airport data, either by checking the means of which are already available as a ADS-B, as a transponder, as information about where the medical services are operating. But according to the EASA, operator needs to demonstrate to the national authority that this is actually 100% and we are able to detect 50 or whatever you need to do. If you see if you go into the EASA, you will see there are listed ways which are acceptable on the low level, and there are some systems which are to be used at the high level of demonstrating the EASA.
Basically, detecting other aircraft if we don't have visual observers means that we have a kind of digital way. So the aircraft which should be detected, it must have a kind of transponder ADS-B FLARM or any kind of remote identification. So the final solution is the U-space, but in between, basically this is based on negotiation with the local national aviation authority.
Yeah.
Yes, definitely agree with that. Just to following that topics, currently our Dock 2 are carried with ADS-B in sensor, and in the future we are also considering to adapt more and more sensor to successfully avoid the air traffic, including the ADS-L or some platform name like Flight Radar. It's all of them are in our consideration. And as Jonas just said, with the U-space industry growing could be slow, but they are growing and providing more and more possibility for a manufacturer like us to integrate and to have a better use space or airspace control.
Yeah, basically in Europe we have a problem of so-called airspace class G, which is a free airspace where everyone can fly, and usually transponders are not mandatory. And that's why we have a problem with air risk.
Yeah. Okay, so next question. Can we fly with LTE or 5G C2 link under PDRA scenarios?
Yes, we can. I think there is only one scenario where direct radio connection is required. I think the standard scenario 1, but basically this is allowed, and it is also very good to have a redundant radio link, so I don't see any problem with that. It just has to be a reliable link, because a lot of times happen that in remote areas we don't have good coverage of the LTE.
It's actually G1 that allows this,
Yeah.
and the others are direct linked only.
Yeah, totally agree with you. Yeah. So next question, also the similar regarding it. Uh, s- so, so you guys think that it will be possible in a legal way, in the technical way, to run the drone in a box without being the pilot present at place, fully remotely?
Uh, of course, it's
Yeah.
the only
It's the
sensible
goal.
thing. So
Yeah.
that's why we are doing. In some countries, it is already possible. For example, in Croatia, where they have digital system for managing the airspace, we can reach with the click of a mouse airspace risk A, so-called segregated airspace, and we can do completely normally all the dock operations. In all European countries, it is possible to get so-called temporary restricted airspace, the airspace which is closed with NOTAM, which is not final solution. And at the moment, we have started the process with the Slovenian National Aviation Authority, where we are looking into the option of creating a geographical zone where the airspace about this geographical zone will be air risk class A. And I cannot say the final solution yet because we are still under process. But we can say for sure that it is possible to operate the dock without the pilot on site, and even without observer, because without pilot we can already do under several PDRA scenarios, but it is really easy to do with the observer on site. So we are looking for a solution to remove the observer.
Yeah, totally agree with that. And from my knowledge, there are already some successful cases happening in Germany, Czech Republic, and other European region country. And they go through the SORA process, and later in the cell determination, they reach to cell 2. With like OSO compliant and all the documentation submitted to CAA, and in the end they obtained authorization. Of course, it's possible, and we all believe it's actually the future of the drone technology. Well, let's go through maybe the last two questions due to our very limited time. No worries. Rest of the questions we will still get in touch with you through the emails. Well, the next question. Let's try to talk about this one. Um, so, how to deal with sometimes high latency when operating the DJI Dock 2. As I understand, there always need to be a human in the loop, but with sometimes a latency of 9 seconds. Is it difficult for the human pilot to intervene if necessary? Well, maybe this question goes to me. This is very product related. Like in our test base, like whether in China or in Europe, we actually like most of the situation, we have the latency within 1 second. Even in the live flight control mode, I mean the I mean the cockpit mode. I think 9 second could be something related to the local network of your router or another transmission link of the network. So basically, we have a control server based in Europe to send out all those like control link, one of the C2, and the latency could be controlled within 1 second. And I believe there could be some exemption according to your like site network or another factors, maybe for understand more situation of this more situation of these questions, I could provide a better solution. Also, after our webinar, we could come back to you with an email and discuss further. Okay, guys, I'm thinking we are meeting the time limits, so and we are good in the question. Now we're gonna conclude today's webinar, and I hope the knowledge of the documentation we shared today was helpful for you guys. And together we are introducing the dock technology into the market, and together we are shaping the future of the drone industry. And my name is Irving, and wish all of you guys have a nice day. Thank you one more time, One Drone team, to join our today's webinar as speaker, and we hope to see all of you guys next time. Thank you.
Thank you. Have a nice day, and we will try to answer all the questions later, which will be available to you. So thank you for watching.
Indeed.
Thank you very much, and safe flights.
Thank you. Bye.